our webinar today. Thank you all for joining us, taking the time to log on. So webinar is going to be around developing a ReactJS application hosted with .NET Core and Kubernetes. If you fancy watching this later, we're going to be sending this out. So watch your inbox for a recording. Also, we're going to be working through some code, so we'll be sharing that on GitHub. And again, we'll be sending a link out with an email after this. Cool, so today we're going to be looking at a number of technologies. And here at Marketing Voice, we've started using them and we think it really does form a really great end-to-end stack. So ReactJS, .NET Core, supporting that, hosting, and on the backend, and then Docker and Kubernetes. So we're not going to be diving really deeply into each of these. Instead, we're going to be taking a whirlwind tour, as it were, seeing how they can work together. Cool. So initially, what we're going to be doing is trying to build something. So often the best way to try out new technology is to actually build something to spike it. My goal today will be to build a really simple front end that can display some banking data, so some bank statement transaction data, and display that to the user. So we're going to spike a solution. We're not expecting it to be fully production ready or tested, that sort of thing. We're just going to see what we can do. Now, the front end, as I was saying before, is going to be in React. The front end itself is going to be hosted on that .NET Core API on the back end. And the back end itself is going to be exposing APIs to that front end. So that's a very similar pattern to what's well known as the back end for front end pattern. So that's what we'll be doing on the back end side. And then together, these will be bundled together in a Docker container. And then what we're going to be doing is deploying that to a Kubernetes cluster. And then just for today, we're going to be deploying it to our local one. Now, you can quite easily, quite seamlessly integrate the deployment and the building of the Docker containers in with your deployment pipelines. Here at MI, we're using Azure DevOps. So we have a pipeline set up that as soon as we create a pull request, merge the master, that gets pushed and built up to our cluster automatically. But today we'll be doing it locally. Cool, so there's a few prerequisites that you're going to need today. So in Docker installed on your machine. So this actually has a local Kubernetes implementation built in, and you'll need that turned on. A second tool we're going to be using today, open source by Google, is called Scaffold. So this kind of aids in the development lifecycle locally with Kubernetes and Docker. So we're using that. Also, .NET Core SDK 2.2. So the Docker container itself abstracts away a lot of these dependencies on the SDK, but because we're going to be building up a completely new application from scratch, we're going to be using the built-in templates. It makes sense to have that installed. And again, Node.js 10+. This will be required for like installing npm assets, running like the Webpack dev server locally with Create React App. And then finally, you'll need something like Visual Studio for Mac or an equivalent. And finally, you'll probably want some sort of front-end editor. So personally, I use WebStorm. Plenty of people also use VS Code, something like that. So those are pretty much what you'll be needing to go through and code along today. We're going to be going quite a fast pace as we don't have too much time and we've got a lot to get through. So I would recommend looking at the recording after and maybe doing it in your own time if you're interested. Cool. So I suppose let's build. Cool. So I'm just in an empty directory here, pretty much. So we're going to start by creating the boilerplate that we're going to need to create this application. So let's just create a directory, dir webinar. Cool. So we've got an empty directory. Now let's start by scaffolding out a new React application. .NET new React out. The reason why we're specifying that is we want our project to be a subfolder. So we're going to probably be using a solution to manage multiple projects. So we might have a unit test, an acceptance test, an integration test. So if we run this, have it as a subfolder, and other test projects can be at the same level. So let's just start that up. Cool. So we have our webinar.api. Now let's create a solution so that we can load this up. So .NET new SLN. That's one of the great things with the .NET CLI. You can do so much from it now. So let's add the project to this solution. So now we have a solution with the project added. We can open it up. Cool. Yeah, so here I'm using VS for Mac. This is just loading up. Cool. And so we can see in here, so we've got all of the boilerplate that we're going to need, all scaffolded out for us, which is really quite nice. So if we take a quick look through, so we have our startup file defined here. Down here we can see we're using a piece of middleware, and here as well, which are hosting our SPAs. And obviously the use MVC route here is going to be our APIs that are exposed to that front end. If we take a look here as well, we get given a sample data controller. So this is essentially just some basic content being returned. Cool. Now, the next step for us is actually going to be to containerize this. So there's a few tweaks that we actually need to make. The first one actually being in this startup CS file here. Now there's a use HTTPS redirection. And based on the way that we're going to be using the deployment locally, we're not actually going to need that. So in our Kubernetes cluster, we're probably going to be having a ingress controller in front of it. And that, in most cases, will handle things like TLS termination for you. So we can remove that. That's not going to be a factor here. Also, down here at the bottom, you can see if development, we're going to use a development React development server. Now, we're not going to be needing that either, as when we're making development changes, we're going to be manually starting up that process. So we can just delete that. That's all we need to do that. Cool. And then next, there's a small front-end change that we want to make before we deploy anything. And this is around service workers. So being able to support offline is great, but for what we're doing today, it might cause a few more headaches in that it'll be caching some of the front-end changes on your browser. We don't really need that. So we're just going to delete this register service worker. And then pretty much, code-wise, that's all good. One final thing, so with the boilerplate that you get from the .NET CLI, you do also get a couple of published tasks built in. So down here at the bottom, we have a target which runs, and it will do an npm install, it'll do an npm run build. So these are the two commands that you'd be running to output your React application. So both of these we're going to be running as part of our Docker build, so we're not going to need these. We don't need it to try to do it for us. And as I'll show you in a minute as well, if you did keep these in, you'll see a failure of the build because the environment in which we're going to be building the Dockerfile won't have access to Node. So we're just going to delete those. Cool. So that's pretty much all we need to actually start to containerize this. So next thing up is going to be a Dockerfile. Cool. So I have a Dockerfile actually here ready for us. So I'll just quickly walk us through what it's going to be doing. So it's a multi-stage Dockerfile. So we've got actually 3 different contexts that we're going to be building in. So the first one is in a node environment. So up here at the top, we are going to be pulling down a node-based layer. We're going to be running npm install as a layer. We're going to be running the build task. And then we're going to be switching into a different context, so into the .NET Core SDK 2.2 environment. We'll be copying over those front-end assets that have been built up in the front-end context. Running the .NET Restore as one layer. Finally, copying over the rest of the assets, running the publish task to get the DLLs out. And then finally, we're going to be using a runtime image, so a slimmed down runtime image for the .NET 2.2. So this will just be an optimized image ready for running in the production environment. And finally, at the bottom, you can see we've got our entry point into the application. So when the container spins up, it's going to be calling this .NET command. You'll see a little bit of duplication here. So some of these build arguments, they don't get shared across these different stages, so we've had to redeclare them. But it seems to be working quite well so far. Cool, so we're going to need a version of this. So if we go into terminal again, clear that, see where we are. Cool, so let's create a Dockerfile here. And just checking the names. I think everything is okay here. Great. Dockerfile. Cool. So now we can just test this out, see if it's working. So let's run a Docker build. So we're going to just build our container. So this might be a little bit slower for anyone who's following along. So I've got a few of these layers already cached in my on my laptop. But you will find the first run is always really slow, and then following up it'll be a lot faster. So let's just see that complete. Yeah, there we go. So just a warning there. Okay, so now it's running the production React build. Cool, that's ready. Copying the layout. Now it's just doing our .NET Restore, so all of our NuGet packages are being restored in one layer, so they should be cached going forwards. And then finally, doing our build and publish. Cool, successfully built the image, great. All right, so let's just see what this is actually doing. Docker run webinar. Actually, let's make sure we put this on a different port. So port 80 to be mapping to say port 5009. In use, okay. I'll go for a different port. Address in use, okay, interesting. This might actually be the wrong way around. So let's just take a look. There we go. Cool. Sure. So this is now running on port 5010. Let's just see that in the browser. Cool. So I'll just create a separate tab. So this is going to be localhost 5010. Cool. We've got that running. We're going to run it over, not HTTPS at the moment, actually. Got ahead of myself there. Cool. So you can see we've got some basic boilerplate code. We're using Create React App on the front end. We've got some basic state manipulation going on there. And if we take a look at our network tab, we are also going to be making an API call here to that test endpoint that we saw earlier in the front end, in the back end code, sorry. Cool, so that's all working fine. Right now, yeah, fronted by Kestrel. Great, so that's a good place to start. Cool. Okay, so next up, we'll actually be trying to deploy this into our local Kubernetes cluster. So we've got a container that can actually be deployed, and we know this is all working, so let's get it deployed locally. So I'll just quickly go back to PowerPoint for a second. So if I take a look at bringing this up for you. Sure, so this is just a basic diagram of the cluster setup, so the Kubernetes cluster setup, if you've not seen this before. So what we have here is just an example request coming in. So this would be pointing at, so you'd have an A record in your DNS pointing to a host that would come into the cloud load balancer, which would then forward requests into our cluster. So you can see the initial line here, we have ingress controller. So this ingress controller, in Market Invoice's case, is Nginx, but that could be, there's plenty of other choices you can have. Nginx is a very commonly used one. So we've got ingress controller at that level. Now, importantly, that's there for listening to ingress resources. Now, those ingress resources, what they're going to do is take a host header, essentially, and then using that host header, figure out how that traffic needs to be routed. So it might be below to A API service, or it might be to B API service. So the ingress is responsible for that. So I'll just pull it up on screen, actually, to show you what the example of that resource will look like. So I've got that here in Visual Studio. So ingress. So here's an example one that we're going to be using today. So we have rules on line 11 here. So what we have essentially is a host. So when a request comes in, it's going to interrogate that host header. And what we're saying is it needs to be routed to the webinar service on port 80. Now, it also handles TLS termination for us, as we were mentioning earlier. So we also need to explicitly reference that host at the top here. And we're also passing in a secret, Ninja Wildcard TLS. Now, that's just essentially the SSL certificate. So that will then be able to handle the TLS termination for us. Cool. So going back to our diagram, the next layer that we have here is a service. So the service will be responsible for exposing a group of containers or pods. So the way that these will work, I'll just pull up the definition, is we have a webinar service that's exposed on port 80. And the selector on lines 8 and 9 are essentially saying that any pods, so in our case, a pod is equivalent to a container, but a pod can, in fact, have multiple containers within it. But in our case, this is essentially saying that any pods with the label app webinar API will be cast as part of that service and be, we will have traffic routed to it. So let's quickly apply these to our cluster, make sure this is all working correctly. So if I end this to start with, so I'll just kill the Docker container that we had running locally. Cool. Now we'll go into our webinar directory. Cool. And so quite often those infrastructural files, they're not actually stored in line with this repo. So at Marketing Invoice, we have a separate repository which handles all of our Kubernetes YAML definitions. For purposes of today, we're going to have this inline. So we're going to have this as a separate folder here. Directory infrastructure, say. Cool. So in our infrastructure directory. So from here, what we're going to be doing then is creating ourselves an ingress resource. And let's just bring it across from over here and my snippets I've made earlier. The first one is going to be our ingress. I'm just going to run a few commands here to see what we have running. So I've already been testing this, so I'm just going to quickly delete a few of the resources that I was testing earlier. So same with services. And kubectl gets element. We should have a clean slate now. I'll just get all of our resources. Cool. So that's just terminating. Great. Okay. So we can start by applying this ingress. Great, so that's created. Yeah, so that's there locally. Now let's actually see what happens if we navigate to this before we even set up the service or anything else. Now, the only thing we need to make sure we do before that is to actually add a host name. So we're going to be working locally. The webinar local isn't going to be pointing to the cluster, the local cluster yet. So we just want to update our hosts file so that webinar local.marketinvoice.ninja heads to our 127.0.0.1 domain. Cool. So as we've got defined here essentially. So I'm going to start then by using I'm going to use a tool called Hostile. It's an NPM module, and it just helps manage these host file changes for us. So sudo npx hostile. That's just going to make sure the requests from the browser are going to go straight to the cluster locally. Cool. So it's added webinar local. Great. Let's see what's going on in the browser there. Cool. So if we go to webinar local.marketinvoice.ninja, 503 service unavailable. Great. So that's exactly what we expect to see. So you can see here we've got a valid certificate, but we haven't got any endpoints or any pods to route traffic. So Nginx is just going to return with this default for now. Cool. So next up, we should be creating our service. So let's just apply our service to the cluster. So nano service. Yeah. So we need. Apply -f. So all this is doing is submitting that YAML definition to our local Kubernetes master to tell it what to do essentially. So service YAML. Cool. Let's just see we've got that there. You can run kubectl get services, .svc. There we are. So important to note here, I suppose then, so this service is given an internal IP address. So then any other traffic inside the cluster would probably be addressing this directly. Now, Kubernetes, you can have kubedns, so you can have an internal DNS system so that you can connect to this from other applications within the cluster. But for now, this is what we need. And now, obviously, we've not deployed any services out to our local cluster yet. So if we go to this request again, we're still going to see 503 service unavailable. Now that's purely because we do not need to, because we don't have anything deployed essentially. Even if the service is there, that service then can't route traffic to anything. Cool. And if we go kubectl get deployments, so any deployments we have locally, we should have nothing. And again, with pods, so containers, we've got no containers. Now, the next resource that we're going to be talking about is a deployment. So a deployment essentially will handle the rolling out of these pods that you can see here into our cluster across multiple nodes. So it might be a case that you define 2 replicas in the case here of service B, or it might be the case that you want 4, in the case of service A, and Kubernetes will handle the scheduling and the provisioning of those services for us. A deployment itself isn't like an underlying type. A deployment will be using various other Kubernetes resources like replica sets to create these resources for us. But essentially what the definition we need looks like is over here in deployment.yaml. So what we have here is a name for the deployment, the number of replicas we want, how we want to deploy that. So we've got a rolling update. So we want to say at most you can provision one extra replica, and at most you can have 1 unavailable at any given time. Then we also have some other variables here around progress deadlines. So this would be around how long something can be deployed out to. This would be around the maximum amount of time that a deployment can take before it's actually live. So if it goes past 30 seconds, the deployment will stall and it will no longer progress. A little bit further down, so labels, app, webinar, API. So this is how the pods are going to be marked. So this is also how the services themselves are able to pick up the pods that are going to be relevant. And then finally, down at the bottom here, we have the name of the webinar API. We have the image that we want to deploy. Image pull policy never, that's just allowing us to pull from our local Docker container repository rather than a remote, which pull it's running on. And then we've also defined an environment variable down here, just so that it's not running as development. But usually we would be running as development. So we can take this across to our repository. And so let's just create that. And now, by all means, we could deploy this directly to our cluster now, and things will become available. But instead, we're going to be using a tool that we find quite useful locally called Scaffold. It's open source by Google, and we found it quite powerful in at least for working locally and to speed up the feedback loop. So in order to use Scaffold, we're going to need to define a scaffold YAML. So I've got a copy of one of these here, and I'll bring this across so we can take a look at it. So all we need to give this is the image name, the location of the deployment YAML file, and the Dockerfile itself, it will know where it is, as we're in the same directory as the Dockerfile, so it will use the Dockerfile it's in line with. So what this will do when so we can run it in 2 modes. We can run it in a dev mode, which will watch for code changes. When it detects one, that will then go into, it will then automatically run the Docker build and then push that out to the local cluster using the deployment YAML. Or secondly, what we can do is run a scaffold run, which will just do a one-time deploy for us. And we'll be using that today. So let's just save this. Cool, so we have a scaffold file. And now let's deploy it to the cluster. So scaffold run. And this is quite a bit faster now because most of the layers are cached. Well, I'm not quite sure why the NPM layer is not cached this time. But yeah, we will just wait for this to deploy, and we should be able to access webinar local.marketinvoice.ninja. Yeah, so usually this feedback loop is fast enough that you can actually run it in watch mode. So yeah, you'd run scaffold dev anytime you're changing your code significantly over, with or a certain period of time passes, it would then automatically rerun this for you, and you can get this feedback loop quite quick. But unfortunately, the npm install task seems to be taking quite a while today. Yeah. So while that's deploying anyway, what we can do is start to take a look at the integration that we're going to be making with TrueLayer. So I'll pull up the TrueLayer console just so that we can take a quick look. So TrueLayer is an open banking provider. Essentially, we can use them to be able to connect with various banks that are also part of the open banking initiative. So let's just take a look at their documentation. So what we're going to do today is pull back some data. We're going to be pulling back. So essentially what we would like is to pull back some account transaction information. So in order to do that, we're going to have to go via the accounts. So we're going to get back all of the bank accounts associated to a customer. Then we're going to pick one of those accounts, the first one, and then we will pull back all of the transactions. So today, obviously, we're going to be using a development environment here. And we're not going to worry about the authentication side. So they have a whole OAuth2 flow, code login. So what we'll do today is pull back an access token manually, and then we'll just hard code that token and then work from there. Cool. So yeah, we're going to be using a auth link builder here, just to go to the login page, and then we can get the code that we need to use to authenticate back. So we'll do that in a second. Let's just see if this says run okay. Yep, so deploy complete. So you can see here, it's just running the deployment, it's created the deployment locally, and if we run kubectl get deployments, we should see a deployment asset, yeah. And we should also be able to see a pod, so get pods. We should see a single container essentially running there, which is great. Now, if we take a look here, we should now be able to see our boilerplate. Yep, perfect. And that's all working for us locally. Great. Okay, so the next step then will be to build out our backend for this. So to make the API calls and to do the integration with TrueLayer. Now, I have a few snippets here as we're pressed for time. So what we can do is use some of these. So let's start by creating a controller to handle this for us. So part of the backend for frontend. So what we'll do here is create a save statement controller. Now, the snippet I've got over here, essentially, is going to expose a get endpoint /API/statement, and that endpoint is going to have make various calls out. So we're injecting an open banking data provider here. We're going to get the accounts back, the bank accounts back. We're going to get the transactions from the first account, and then we're just going to project that into a layer, into a result object. Take the top 100 of those transactions and return those. So let's just bring this across. Now, clearly we haven't defined our open banking data provider APIs yet, but we can bring that across in a minute. So this interface. So what we'll do then is pull across the open bank, the true layer data provider that we defined here. So this is nothing too complicated. I'll just quickly run us through it. We're using Newton.json, serialization of the responses. And so we're using this Fluent HTTP client. Then, now this is just a simple Fluent syntax around the HTTP client to make our life a little bit easier. So I'll just pull this in as well. Yeah, it's nothing too crazy. Cool. I'll just put that in here. Cool. So it's a few dependencies we need. TCP responses, dictionary, and Unsoft. Cool. Yeah, this is a Fluent syntax, essentially wrapping a HTTP client. At our true layer data provider level, so looking at the docs, all we're doing is making a GET request for the bank account details based on the token that's being passed in, so the user access token. And then again, for the GET transactions, we're passing a bank account ID using the token that's passed in and just making a GET request. So that's all we're doing here. Nothing too complex. Cool. And then naturally here in the controller, pulling back that data, mapping it, and then returning it. So now that should work. So what we'll do is build this and get it working locally. So we can just run scaffold dev to get that into our cluster. Actually, let's run scaffold run, then into our cluster. So the reason why we're doing this is we're going to run a Webpack dev server for our front-end changes. And we essentially want to proxy any of those Webpack dev server requests across to this webinar local API. So we're not going to have to worry about rebuilding this every time we change the front end. We can decouple the two, and you get the faster feedback loop there. So deployment complete, that's all running now. Let's just see it. Make sure that the endpoint's actually working. API statement. Okay, so we've got an error. It's interesting. Let's just take a look. One moment. Okay, so we've got an error processing error request at the moment for this. Okay. Of course. Now, usually you would be writing our acceptance tests and our integration tests and everything around this, but alas, today, as we're spiking, this hasn't happened. So what we'll have to do, of course, is we've got to bind it. We've got an injection here. We've not set up any bindings. So what we need to do is go into our startup file, and we actually need to bind this provider. So let's just go into the setup here. We're using the built-in BI framework that comes in ASP.NET Core. So let's just add a transient. So I provide open banking data. And you'd probably be injecting some configuration that comes from app settings, but let's just directly hard code our string. So we're going to have a new two-layer data provider. And here, I suppose we're going to have a token, our access token. Our token equals blank string for now. So that should work. Now let's go about getting an actual access token to pull back that data. So test this. Cool. So today I'm going to allow access for Market Invoice to access my banking data. And so this UI is all provided by TrueLayer. So I'm going to use a mock bank, and I'm going to log in here. So John. Cool. So that's just redirected us to webinar local. So what we've got here is a code that we need to use to authorize. So let's just take that code. And I've got Postman open here for us. So we should be able to make a request. Yeah, webinar. Now I've saved a few earlier so that we could go about this. Cool. So code exchange for access token. So all we're going to do is obtain an access token for us here. Cool. So code. Just put that in. So this is just a post request, form URL encoded, standard auth2 stuff. We're just going to obtain an access token. Cool. And yeah, for now we're certificating this, but you'd want to be doing your redirect. You'd be wanting to handle a redirect back to this your application. But for now, we're just going to be hard coding it. Cool. Yeah, let's just pull it in here for now. Cool. Now we should get to rerun the scaffold run. That was much faster, as you can see this time. So yeah, as you can see, the feedback loop becomes really quite quick. And yeah, you can almost always run the scaffold dev instead of explicitly running it each time. Cool. So I think we're almost there in terms of the implementation. That's running locally. So let's just make sure that the API is responding as we expect. There we are. Cool. So we've got data coming back from that API based on an integration with TrueLayer. Great. So the next step will be to expose that on the front end. So what we'll now do then is go into our client app. So open our API. I'm going to go into our client app directory, and I'm going to open up WebStorm so that we can do some front end code. And like I said, we're going to decouple this, so we're going to run this in Webpack Dev Server and proxy across to our API that's currently exposed on this webinar local domain. So let's just wait for this to load up. Cool. So a few changes we're going to make, I suppose, to start with to our package.json. So firstly, we're going to run this over HTTPS. So I'm going to make a quick adjustment to our start script. Now this is all boilerplate create React app. So you can learn more about that through the create React app documentation. But we're just going to set HTTPS to true. And then finally, we're also going to add a proxy variable here. So what we need to do is proxy this to our local link. So any API calls that are matched are going to go to this. Cool. We should be able to run this. npm start. Let's see. Okay. HTTPS is true. React script's not found. Okay, so that's just an npm install that's not been run yet. That's fine. So yeah, just install the dependencies, and then we should be able to pull that data on the front end. So that's installing. I'll quickly head into our application. And what we can do is define a new page. And let's get a component for this as well. And what it's going to do is export default. And let's just return a clear hi. Okay, usually this helps out. The website's really good at hinting. That's probably not going to be working while we're doing npm install. I'll just import React explicitly at the top there. Cool. So that statement there. Okay, so we're updating indices. Okay. So let's just import it explicitly. This is a default export from build task we want to start. Cool. Just to spin out. So we'll spend about a few more minutes just pulling this data in on the front end, and then we will have a bit of time for some Q&As. Cool. This is now spun up, and we should be able to see this is now running locally. We can fetch data, and also if we make quick changes, what we can also see over here is, if we go to the home page, hello, webinar world, it will update very fast. Cool. Okay, so if we go to the statement endpoint, you can see our hi. Okay, cool. So we're going to just install one final dependency here, which is going to be npm install Axios save. So it's going to use Axios to do our API call for us. And let's just define a table for this data. So let's change this to being a class. So actually, export default class and use React component. So now we're going to be doing our API call stuff here, and then render. We're just going to render some stuff. We want some local state. So loading is true, data is going to be empty, and if loading if we're loading, we're just going to return div where it's loading. Otherwise, what we're going to do is return div for a table. Inside that table, it's going to have some TRs, so table rows. So what we can do at the top here is const table row, and we'll just pass in description and an amount. And we'll return a TR. And inside that, we'll have PD, description, PD, amount. Cool. And now all we need to do is map over that data. So data.map. And what we're going to do there is for each element, we're going to have a table row. Cool. And for that key, so we're going to have a key which is going to be data.id. We're going to have a description equals data.description and a amount, delete data.amount. Cool. So that should all be there. And data, of course, is going to be coming off our state, so we just need to deconstruct it at the top there. That's what we're going to do, is pull back those rows. And Axios should be installed now, so what we can do is rerun our dev server, and while that's starting up, I will make the relevant Axios call. So axios.get, so this will be /API/statement. Here we are, /API/statement. Yeah. And then res this.setState. And we're going to set data to be res.data, and we're going to set loading to false. Of course, we need to import Axios. Okay, that's not, WebStorm's not been very useful there, but let's just import it out here. Make an API call on mount, saturate the local state, and hopefully render some of our data. There we go. Perfect. So there's more fields, so we could be also pulling back dates, and obviously you can format this using things like React Bootstrap. But yeah, given the time, I think we probably should move on to questions. Cool.
Mason, can I ask, why did you choose to use Kubernetes rather than other deployment tools and methods?
Okay, that's a good question, because like any technology like that does introduce some complexity in it. So initially we were looking for new ways of deploying and running our services. So there were some limitations with the Azure Platform as a Service web apps that we had. One of those was around load balancing. So the implicit load balancer in web apps just wasn't sufficient for what we were doing. Other things as well, so lack of network control, so around outbound IP addresses, that sort of thing. And there were a few solutions out there when we started looking. So things like app service environments, which the cost benefit didn't really make sense. And also there were things like VPNing those web apps directly into a VNet integration. But those were quite flaky. We found that you'd lose that VPN connection quite easily. So we didn't want to make a regressive step back to like managing our own VMs. But we started looking, we didn't go straight to Kubernetes, we didn't jump straight into it either. We explored a few solutions, so Service Fabric was one other example. But we found like in the end that I guess Kubernetes with Docker pretty much provided a good balance of control and flexibility that we kind of really wanted here. We didn't jump straight into it either, so yeah, we took small steps. We started with a very small single service that wasn't as critical to our business, deployed that out to production. We monitored it. We established some patterns along the way as well. Like introducing any new technology like this, naturally you're going to need to spend some time actually spiking things and establishing patterns. And then it worked very well in production. So we slowly pulled more systems across. So I think right now we have 3 or 4 APIs that are deployed into our Kubernetes cluster. And yeah, it seems to be working well for us right now. Hopefully that answers the question. Okay.
How does the Kubernetes cluster integrate with your services?
Okay. So there's 2 parts to it, I guess. So how locally and also like in the cloud, because there are some differences for sure. So at least locally, we have some hosted services that are still on web apps. So locally, they're going to be on IIS. And we have someone in their local cluster as well, in our local cluster. So there's some configuration, especially on Windows, like to be able to get them to play nicely together. So we've written a number of scripts that we use to actually set up IIS to act as a reverse proxy. So what happens there is any requests that don't hit an IIS website are then forwarded onto the cluster. And we've got the cluster running, or exposed at least, on a different port. So it will reverse proxy to that different port, and it allows us to run IIS and Kubernetes cluster locally at the same time. So that's a little bit of friction, I suppose. But as we move more stuff to the cluster, it should become less of an issue, I hope. Remotely, I guess generally we've not had any issues. But like one advantage, if you had everything in a cluster, is all of the internal services are within that cluster, and you don't have to. You don't have to worry too much about your ingresses. But for us, because we have some internal services that need to access other internal services that are hosted in our cluster, we have to manage like an IP restriction list for our ingresses, which we currently do for our web apps anyway. But as we move more and more towards it, I think we can get away from that. That's a little bit of friction, but in general, it's not been too bad at all.
How do you manage communication across microservices? E.g., does your architecture have an IPA gateway which talks to services? What protocol? HTTP, RPC, etc. Finally,
okay.
Do you use async messaging such as Kafka?
Okay, so yeah, that's a good question. So our services right now, we have mostly they are communicating over direct like REST API calls. Now, like jokingly, that can be to some extent be called a microlith. So you've got the fragility of having that that direct synchronous call. So if that fails, then obviously you're in trouble. And I suppose the uptime of one service then is also to some extent going to be the product of all the uptimes of the other services in that situation. But we don't just use direct synchronous calls like that. So we do use asynchronous patterns. So we've got Azure Service Bus. So we use that essentially for most of our asynchronous messaging, most of the worker processes that pick up queues. We've pretty much implemented like a pub/sub sort of model there. And so both systems outside of our cluster and in the cluster can consume that. We've not used Kafka, but yeah, it's purely the majority service bus, and I'd say we're moving more and more towards async messaging rather than direct REST API calls.
Strategies you have to manage a backend data structure that works best with the combination of React, Core, and Kubernetes?
A backing data structure. So, okay. So would that be in terms of the persistence layer? So like databases, that sort of thing? Hopefully, I guess the feedback here is quite limited. So assuming that you're talking the persistence layer, so things like SQL servers, Redis, that sort of thing. So right now we've gone down we've taken the approach, and we've used this approach for quite a long time around managed SQL Server instances. So with Azure, you've got managed SQL Server, managed SQL Azure, which we use currently. So we're not hosting any persistence within the cluster. We haven't needed to. There's a few volumes that we mount within the Kubernetes cluster for certain certificates, but apart from that, it's fairly stateless. When it comes to, I think there's a similar pattern as well with other providers. So things like with Google Cloud, for example, you've got their own SQL providers, and you have a similar strategy of having like a sidecar pattern where you have a pod which has 2 containers within it, and the sidecar container within that would then be handling the communication with whichever database you're using. In our case, it's just SQL Azure, Redis as well.
I think that's all for questions. Maybe we'll give it a couple more seconds if anybody's got any more, and then I think we'll call it a night.
Okay, cool. Yeah. Yeah, thank you everyone for joining us.
I think that's all. Thanks, Mason.
Okay, great. Bye. Thanks everyone. Bye.